All right, in this lesson we are going to look at how to determine the domain and range from a rational function that's been graphed. So I didn't actually give you the equations in this particular lesson. They've already been graphed for you, but hopefully you have that kind of down from previous lessons. So what you want to do when you do domain and range is pay attention to where the vertical asymptotes are, where the horizontal asymptotes are, and where you would have any holes. So in this case, they're not marked, but I do have a vertical asymptote. You can kind of see it here at x equals -3, and I have a horizontal asymptote here at y equals 0. Okay, so there's a couple of different ways that you can do this, and I will show you those. But this is what you're going to think of doing. So remember that when you do domain, you're going to think about all the places as you move from left to right, you would be touching the graph. In this case, the blue line. Okay, so as I drag this vertical line from left to right across this function, I'm looking for all the places the pink would touch the blue line. So all the way down to -infinity, it will touch, and it's still touching the blue line, and still touching the blue line, and still touching the blue line, and still touching the blue line. Right here, however, there's a gap. There is an imaginary line where nothing touches it, okay? So basically what has to happen there is that x equals -3 can't be part of the domain because the graph does not exist there. And then as I move to the right, it's not letting me grab the line. Here we go. I'm touching, 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 and it's going to keep going because that blue line is going to move off to infinity, okay? So, couple different things that you can do when you do this. So first of all, I'm going to do it in interval notation because that I think is easier for people. So we went from -infinity, and then it didn't touch at -3, and then there's a gap there, and it picks up again from almost -3 to, positive infinity. Okay, so there would be my domain. When you do your range, or when you do your set notation, you can do this a couple of different ways. Some people will write it like this, such that x is all real numbers except x can't be -3, okay? So that's one way you can do it. It can be all real numbers except it can't be -3. The other way people will sometimes do it is they will say x can be less than -3 or x can be bigger than -3, but x can't be exactly -3. So you pick your poison and decide how you want to write it. Either one of those would be fine, okay? And then when we do our range, we're going to drag the line this way. So it's gonna be very similar here. Again, my pink line is touching the graph, touching the graph, touching the graph, touching the graph, touching, 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 touching. It's touching the blue line. I have a gap right here though when y is 0. And then again, just above 0, it starts to touch it all the way until I get to infinity, okay? So for your range, you would go from -infinity to 0. And again, from 0 to infinity. Remember when there's parentheses right here, it means that it does not include that value, but it gets really, really close to it. And then for your range, you would do the same thing. You can either tell me it's every real number except 0, it can't be 0, okay? Or you can tell me that y has to be less than 0 or bigger than 0. Okay, so you can do either way, is totally fine. All right, we're going to skip this one because it's really repetitive. And then let's go to this one. Okay, so again, this has a vertical asymptote at -4. And again at +3, okay? And I have a horizontal asymptote at y equals 0. Okay, so as you drag a line from the left to the right, you can see that it would be touching all the way out to negative infinity, touching, 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 touching. It doesn't exist at -4 when x is -4, but it exists everywhere in between, and then the graph doesn't exist at x equals 3, and then it exists every place after that. So for your domain, you would go from negative infinity to -4, and then from -4 to 3, and then again from 3 to infinity. Okay? Your domain, you can do a couple of different ways in set notation. So one way you could do it is you could tell me that x is every real number except for it can't be -4 or 3. Okay, so you can do it that way. Or you can tell me that x is less than -4. Oops, I said -4 but wrote -3, sorry. X is less than -4, or x is between -4 and 3, or x is bigger than 3, okay? So either one of those ways would be absolutely fine, but it's every x value that's less than -4, every x value between -4 and 3, and every x value bigger than 3. It just can't be exactly -4 or 3, okay? For your range, when you drag that pink line, I'm going to just draw a new one, it'll be faster. When you drag the pink line from the bottom to the top, again, I'm touching the graph, touching the graph, touching, 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 touching. The graph doesn't exist when y is 0, but it does exist everywhere above it. So you would go from negative infinity to 0, and then again from 0 to infinity. And then for your range, up here, again, you could tell me that y is every real number except 0, or you could tell me that y is less than 0 or bigger than 0. Okay? Either way you want to write those is totally fine. All right, and then here's another one. I am going to just add a hole in this, and I'm just going to say that there is a hole right here. I know you don't have this, but why don't you add it, because we're just going to, okay? And I am going to say that the coordinate of that hole is at 1 and -1/2, okay? And I do have a horizontal asymptote at y equals 0, and I do have a vertical asymptote at x equals 0. Okay, so now, when you do this, and you do your domain, this is where this gets to be just a little bit tricky. You have to know the coordinate of the hole. So when I drag this, I'm touching the graph, touching the graph, touching the graph, touching the graph, touching the graph. I don't know why I drew a vertical asymptote at x equals 0, because there isn't one. Sorry. There is a vertical asymptote over here at x equals 3. Sorry. Okay. Anyway, so let me start over. I'm dragging the line, 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 dragging the line. Right here, there's a hole. So your x does not exist there, nor does your x exist where there is a vertical asymptote. So it doesn't exist here at 3 either. So your graph does not exist when x is 1. Your graph does not exist when x is 3, but it does exist everywhere else. So you would go from negative infinity to 1, and again, that's where your hole is. And then again, from 1 to 3, that's where your vertical asymptote is. And again, from 3 to infinity. Okay? And up here, I personally think the easiest way to do this is to tell me that it's every real number except it can't be 1 or 3. Okay? If you want to do it with inequalities, that's fine too. And then for your range, you're going to go the other way. And when we do it like this, again, my graph exists, and it exists, it exists, it exists, it exists, it exists, till I hit the hole, and then it exists again between the hole and the horizontal asymptote, and then everywhere above the horizontal asymptote. So that's why I make you give me my hole as a coordinate, because you need the y value of your hole as well. Just a reminder, you get the x value of your holes by figuring out what factors cancel, in the numerator and denominator. And then you take the simplified version of it and you plug your x value that you just canceled back into your equation to get the y value of your coordinate. So just a reminder that that's how you do that. Anyways, so for my range, I'm going to go from negative infinity in this case until I hit my hole. The y coordinate of my hole was negative 1/2. And then the graph exists again from my hole till when I hit my horizontal asymptote, which is at 0. And then again from 0 to infinity. Okay? And for your y's, you can tell me that y is every real number, but y can't be negative 1/2 or 0. Okay? So that should do it for this lesson.